Picture a pot of water on the stove. It's a scene that's probably very familiar to you. We've all seen it bubble and boil countless times, whether we're making a simple cup of tea or preparing a hearty meal. It's how we make pasta, tea, and countless other dishes that bring comfort and joy to our daily lives. But have you ever stopped to think about the science behind this everyday occurrence? It's more fascinating than you might think. Heat makes the water molecules move faster and faster, causing them to vibrate intensely. They bump into each other with more energy, creating a chaotic dance of molecules. Eventually, they break free from their liquid bonds and turn into steam, rising as bubbles to the surface. This simple act of boiling relies on a crucial force: gravity. Without it, the process would be entirely different. It's easy to overlook its role, but gravity plays a big part in how water boils here on Earth, ensuring that the bubbles rise and the steam escapes. In space, without gravity, boiling water behaves in a completely different manner, forming a floating, chaotic mass of bubbles. Scientists study this to understand the fundamental principles of physics and how they apply in different environments. So next time you see a pot of water boiling, take a moment to appreciate the intricate dance of molecules and the unseen forces at play. Gravity keeps us grounded on Earth. It also affects how water boils. Imagine those energetic water molecules again. As they heat up, they want to escape as steam. But gravity pulls the heavier, cooler water downwards. This downward pull of gravity creates pressure on the water. The hotter, lighter steam bubbles have to push against this pressure to escape. That's why we see those characteristic rolling boils on Earth. Gravity keeps the water contained, while the steam fights its way to the surface. Now, let's blast off into space. Up here, things are a little different. Without gravity, there's no downward pull. This means that water behaves in a very peculiar way when you try to boil it. Remember those buoyant steam bubbles? In space, they don't rise to the surface and escape. Instead, they stay suspended within the water. The water doesn't bubble and churn like it does on Earth. It's more like a cosmic dance of water and steam, all jumbled together. Section 4. The pressure cooker of space, how it affects boiling. But that's not all. The unique environment of space presents a fascinating challenge for scientists and astronauts alike. Space isn't just about the lack of gravity. It's a place where the rules we take for granted on Earth don't always apply. It's also about the lack of air pressure. This absence of pressure changes how everyday processes like boiling water occur. On Earth, the atmosphere exerts pressure on everything, including water. This pressure is what keeps water in its liquid state at room temperature. This pressure affects the boiling point of water. Under normal atmospheric conditions, water boils at 100 degrees Celsius. In space, the near vacuum environment means much lower pressure. This drastic reduction in pressure has a significant impact on boiling. And lower pressure means that water boils at a much lower temperature. In fact, water can boil at room temperature in the vacuum of space. Imagine trying to cook pasta in space. The water would boil much faster, but it wouldn't get hot enough to cook the pasta properly. This presents a unique challenge for preparing meals in space. Astronauts have to use specially designed equipment and techniques to ensure their food is safe and edible. Section 5. Astronauts and space cuisine. Overcoming boiling challenges. So how do astronauts deal with these unusual boiling conditions? They have specially designed equipment that helps them. For example, they use special ovens that create artificial pressure. This allows them to heat food to the correct temperature, even though the water boils at a lower point. They also have special pouches for drinks and soups. These pouches are designed to prevent spills in the low-gravity environment. Section 6. Space boiling, a universe of difference. Boiling water, a seemingly simple act, reveals a universe of difference between Earth and space. On Earth, we take for granted the way water bubbles and steam rises. In space, however, the absence of gravity and the low pressure create unique challenges for astronauts. Water behaves unpredictably, forming floating spheres instead of rising bubbles. But with ingenuity and specially designed equipment, they've found ways to overcome these obstacles. Engineers have developed tools and methods to heat and manage water in zero gravity. They can enjoy a hot meal, even while floating amongst the stars. Specially packaged food and innovative heating techniques ensure that astronauts can dine comfortably. From a bubbling pot on Earth to a cosmic dance of water and steam in space, the science of boiling is truly fascinating. The behavior of water in space offers insights into fluid dynamics and thermodynamics. It reminds us that even the most familiar things can behave in unexpected ways when we leave the comfort of our planet. Space exploration continually challenges our understanding and pushes the boundaries of science.